space. Yeah. So implementation of infix to postfix. Again, since I'm using
Okay.
namespace std, right? See, we are going to see we are using stacks here. So stacks we are also we are doing push and pop operations. So we have to write those logic also. Okay, we have to write that logic also. But before that, we have to define the stack. So I'll write in, maybe I'll give some no max value hash, define some m as 100. Okay, then I'll give int this, what we say, this is character array, right? Character some stack of m, right? Why am I defining it as character? This is a stack. Why I gave character? Because the input here is infix expression, which is a string. So I gave s of m. Okay, you can also give int top is equal to equal to -1 initially, right? Now I have to implement two functions: void push of a char variable character ch, and also I have to implement void pop function, which will not take anything, like this, right? Push and pop. I have to implement these two, but generally we return the character, so I will write character pop, and I will return here some we will return some value here. We'll see about that. So push operation, pop operation. Then I should have my actual logic, that is converting that to postfix to prefix. So I will write some void function infix to postfix. Okay, some expression. What will be my input for this? Input will be the input expression what I am giving. Whatever input string I am giving, that will be my. So again, it will be a kind of a pointer, because I am taking a string directly. I will talk about this part. Let us just build the skeleton of the program first. Okay, then after this I will have my main operator. So main will just take this int main, right? Here you have to write cin, or maybe you can write a message cout, enter the infix expression, and L, then cin, declare a string first, right? So char some ch of, or maybe we can write string directly, string yes tr is equal to, let me give some a plus b minus d c into d by e. Okay, some simple expression I have given here as a string, right? String str equal to, I have given a string. Then this is not required, sorry, we will take it like this only manually, right? Now I have to pass this to this function. I have to call this function here, right? So we can give the parameter as str. That's it. I will write return 0 here. Okay, so I have to implement push function, pop function, and also infix to postfix. Let's quickly write push function. How to do that? Whenever, what is the logic of writing push here? You have to check if the top value is equal to first step. If top is equal to that m minus 1. Why m minus 1? Because m is max. Oh, I gave x, no? Let me make it m. Yes, define m 100, s of m, right? So I'm checking if that top is equal to max minus 1. Then I have to throw a message saying that the stack or stack overflow. I can give it like this. Otherwise, what I have to do? You have to insert it into the top of the stack by incrementing the top value. So it is nothing but s of plus top is equal to that character ch, the character ch. So this is simple logic. S of top plus increment the top value and copy that new character into the stack. Now how do I implement pop function here? Again, I have to write if top is equal to -1, or maybe other way you can write less than 0, right? Then you can say cout stack underflow and else what do you return? You have to return this s of top minus minus, okay, s of top minus minus. So this will pop the element and give it back to you. It will pop the element and give the top element and then reduce the top size. Then comes implementing our logic. What was the logic of infix to postfix? Whenever we see I am passing a string here, so definitely I have to use some pointer like this. Let me call it as infix. Okay, let that input be infix. I am receiving this string in this new variable infix. Now, what is the logic? Iterate over that infix expression. How can you iterate over the infix expression? By writing a for loop. So for some int I equal to 0, how long should I iterate? I have to iterate it until I encounter a null character. Or you can calculate length also, that's also fine. So we can even write it like this, something infix of I is not equal to single quote null character. Okay, then what I can do, I plus plus. Now what is this for loop for? This for loop is to iterate over each character. Now we have to write our logic. If the first character is an operand, directly push it to the output. If it is an open bracket, do something. If it's a closed bracket, do something, right? So we have so many steps here. Those steps will write as if conditions. So what I will do, I will take the first character, some character, maybe C is equal to this infix of I. I am reading the first character, putting into C. Now I have to write a function. I have to check whether C is a variable or not. How do you check whether C is a variable or not? How can you verify it? Right? So if that C is equal to single quote A, and if C less than or equal to single quote Z, can I say like this? No, we can write it like this. No, I want to check whether it's a character or not. So I am implementing for both small and capital S. Though I have given small a here, program can contain anything. So let me put round bracket here and put this. Okay, so this is just to verify or if C is greater than or equal to small a and C is less than or equal to small z. Okay, and what else can happen here, right? In this case, what I have to do? Okay, we have to, no, this means it is true. In this case, what you have to do, I will open bracket, close here, right? What is the algorithm? Whenever you encounter a character that is small a or capital A something, you have to add it to the expression. Right? For that, I have to create one output here. Let me declare a character. Let us call it as postfix of some maybe m. Let's give some large value for now. Okay. Now this is my output. String. So whenever it's a character, what I have to do? Insert it into this postfix. So I will write postfix of plus some j. I will declare that variable equal to this C. So I will declare another variable here, int some j is equal to 0. Yes. No, j equal to we can give j, or maybe postfix j plus plus I can give here. J plus plus and give j value as 0 initially. Okay. See what I am doing. I have just implemented the first logic. In the algorithm of infix to postfix, the first step is iterate over the entire string. Okay, I am iterating with this. If the first character or whatever character you are iterating, if that character is an alphabet like this, if it's an operand Operand means some A, B, C, something like this. What you have to do? Just add it to the output. Just add it to the output. So for some readability, oh sorry, just make it neatly. Right. Okay. Now, next, yeah, if ended here. This case is over. If it is a character, what is the next case? Else if. What is the next case? If it is an, if the if it is the operator is an a round bracket, no. If the operator is an round bracket, so else if that ch, yeah, it is C. If C is single quote this bracket, if C is single quote this, what I have to do in this case? What I have to do? If it's an open bracket, add it directly to the, call the push function and add C. So this will add it to the string. Again, else if, we have another else if C is equal to single quote close bracket. Now what you have to do? If in that case, what I have to do? I am implementing the steps. If it is open bracket, add it to the stack. If it is close bracket, we have to pop out. Till when I have to pop out? Till I encounter a open bracket. Okay, till I encounter a open bracket, I have to pop it out. So if C is equal to close bracket, what is the logic? You have to do pop out. You have to do pop. So after popping, what I have to do? After popping, I have to add them to the stack. So while that C is not equal to while the C, or no, not that, while S of top is not equal to single quote open bracket. Why I am writing this? Until I encounter the open brackets. What I have to do? Until I encounter open bracket, what I have to do? You have to add that to output. You have to add that to output. That's it. Instead of this, I will put here pop. Right? What does it means? See, if it's a close bracket, right? So stack of top is not, until it is not equal to this open, keep popping out the elements. Keep adding that to the expression. Right? So with this we complete while, and this if else is over. Then else, what can happen? Either it can be a character like this, or it can be open bracket, or it can be a close bracket. The last case is it can be an operator. So else, it means it's an operator. What you have to do here? Right? What you have to do here? You have to check the precedence. of these operators. Again, simple thing, it is nothing but just again postfix of some j++ is equal to pop. This I have to do it. Okay, this I have to do it. After this, I have to, no, in this I have to push that element to the, no, C. Okay, if it is a plus symbol, I have to check the, that is pending yet here. Okay, precedence checking is pending. I'll just to make it simple, I am not writing that logic now, just explaining you. See, once again I will go back here. We are writing a function infix to postfix. The algorithm states that you iterate over the entire string. Okay, I wrote a logic for that. Okay, I have defined an output string for me. Now, if that is a character, if it is a variable, add it to the output string. If it is an open bracket, add it to this stack. If it's a close bracket, until you encounter the open bracket, keep popping out and add it to the stack. Okay, add it to the output screen. That also I have done. Now else it means it is something like, no, it is something like no, if it is a operand. Okay, if it's an operator, how do you check if whether it's an operator or not? If C is equal to plus, C is equal to plus, double equal to, C is equal to plus, or C is equal to minus, or C is equal to star, sorry, or C is equal to divide by, right? If it is any one of these, if it is any one of these, what I have to do? If this is an operator, what I have to do? I have to no compare the precedence of the stack element and the current character, and whichever is no matching, that you have to push it into the output expression. So here I'll write one checking. I'll write one checking logic. What is that logic? I'll be writing while, okay, while I have to check the precedence. So we have to define a precedence function. Maybe this is closing here. I'll write a precedence function. Okay, you have to write this precedence function also, right? So int some precedence of the character, okay, some variable char ch, right? What I have to do? If the ch is equal to into, okay, or ch is equal to divide by, then sorry, you have to return some value, maybe 3, okay, 2, because we are implementing it. Else if, okay, no, we don't need else if. I'll write simple if ch is equal to single quote plus, or ch is equal to single quote minus. In this case, return 1. So I am taking priority here, that's it. So either it will return 2 or it will return 1. Okay, so I will check here while the precedence of, while the precedence of which value now? The top of the stack, that is s of top of the stack, while the precedence of the top of the stack is greater than or equal to the current character precedence of this current character. If the precedence of the top of the character, top of the stack is greater than the current stack, current operator, what you have to do? You have to insert that into the, add that top of the stack to the expression, right? So it is something like this. To more clarity, it means top of the stack contains multiplication and the current character came to be minus. So minus is having less priority, but top is having more priority. So you have to add that to the output string by popping it out, and after doing this, you have to push the value as it is. Okay, you have to push the value into that minus, you have to push into the stack. Okay, so this is what the logic for doing that, right? Let us see, and also I have to print the output. No, before this I have to print the output. So this postfix contains that value. Postfix contains that value, right? So see out, no, the postfix expression is, postfix is the name of that variable. Okay, hopefully I think we will see if some error comes, we'll try to rectify, but I will repeat the implementation here. This is normal push operation, this is normal pop, and I have defined a precedence function to give these numbers like this. I could have written there also. Then we have this no infix to postfix function. We are creating a string postfix. I am iterating over the entire infix string. I am taking each character. That character I am checking if it is an alphabet, enter into the output. If it's an open bracket, add it to the stack. If it's a closed bracket, until you encounter open bracket, keep popping out and add it to this string. Then if it's any of the operators, check the precedence of the current stack top and the current character. Accordingly, you do this. If it is not, simply push that into the stack, right? Then you print the expression as postfix endl, right? So in the main, I am giving this. Hopefully, it should execute. Let me see this output. Something is missing here. Oh, this additional return is there here. Let me execute. Yeah, cannot convert this to string. Oh, since I am sending it there. Okay, let us take that using cin. Let's give as a character only, character array. char some str of some m, cout, enter the infix expression, c in str, okay, right, postfix. Now let's see, yeah, it is asking me enter the infix expression, so I'll give a plus b, whatever we gave it here, yeah, a plus b minus c into d by e. The postfix expression is a, remaining things came, right? Let's see what mistake we have made it here.
Your voice is breaking, sir.
See the output here. We have just added a logic here. Why? The last step of the algorithm is that if everything is over, after iterating over the entire string, right? If there are some remaining items left over on the stack, pop it out everything, add it to the postfix expression. Okay, so we are getting this. Let's execute this and see. Enter the infix expression a plus b minus c into d. See, ab plus cd star minus, right, where you can see the output here, cd star, then ab plus and minus. Okay, so we are able to see the expression. So this is the implementation of no infix to postfix. We can improve this still. Maybe there are some small changes, we can do it in that, but this is the implementation of infix to postfix expression.